Hey, 7th grade. In this video, we're going to explore two concepts. The first thing we're going to do is we're going to review what the term exponent means and how you use exponents, and then we're going to apply that to something you should all be somewhat familiar with, and that is the order of operations. So let's go ahead and first of all start with exponents. Just a reminder before I begin, you can have a basic calculator for these problems that we're going to do, just not a scientific or a graphing. So if you have a basic four-function calculator handy, feel free to grab that. If you have the calculator app on your iPhone or Android, feel free to grab that, just not in school, but for a home that's fine, and you can use that to help you with some of these problems. Okay. So just to review, using exponents is really just a shorthand way of writing repeated multiplication. That's all an exponent is. It stands for repeated multiplication. And so if you had the multiplication problem 2 times 2 times 2 times 2, okay, 2 times itself 4 times, a shorter way to write that would be using this notation right here, and we say 2 to the 4th, or 2 to the 4th power, is how we read that. Now, the most common mistake I see is students seeing this notation 2 to the 4th power and thinking that means 2 times 4. So make sure if that has ever applied to you, you highlight this next part. 2 to the 4th does not mean 2 times 4. It means 2 times itself 4 times. So if we do 2 times itself 4 times, if we take 2 times 2, that gives us 4. Times 2 again would be 8. And then times 2 one more time, that's the 4th time, that would give us 16. So 2 to the 4th power is really equal to 16, not 8. Okay, let's go ahead and define some terminology in this little notation right here. So when you see this 2 to the 4th power, the entire thing itself is what we call a power. So the 2 and the 4 together is what's called the power. The power can be broken up into two separate parts. And so the 2, the big number, is what we call the base. So if you ever hear me refer to the base, I'm talking about the big number. In this case, it's the 2. The 4, the tiny number, okay, that's how many times we're taking the base times itself. That is what we call the exponent. So when you put a base and an exponent together, you get a power. Okay, so now that we've reviewed powers a little bit, we're going to go ahead and go down and talk about order of operations. And the first thing I want to clarify is, what's the big deal? Why do we have an order of operations? Okay, well, let's take a look at this problem right here. We have 3 plus 5 minus 6 divided by 2. Okay, so let's say I'm Billy Bob, and I'm over here working this problem on the left side. Okay, and Billy Bob just decides he's going to go left to right. So he does 3 plus 5 first, and 3 plus 5 he knows is 8. Then the next thing he does is take 8 and subtract 6, and he knows subtract 6 is 2. And then finally, divide by 2. 2 divided by 2 is 1. Okay, so Billy Bob says the answer is 1. And now Sally Sue over here decides that she doesn't want to go from left to right. She instead she still wants to follow her signs, but she wants to go ahead and do this division over here first. So she knows this is a negative 6 divided by positive 2, and so she knows negative 6 divided by 2 is negative 3. Okay, then she decides she wants to bring down this positive 5, and she wants to do 5 minus 3, which is in fact positive 2. And then finally she wants to take this 3 here, 3 plus 2, and she gets 5. Okay, so we took the same problem, and Billy Bob over here got 1, Sally Sue over here got 5, and so a long time ago there were two mathematicians that probably had a problem similar to this, similar to what Billy Bob and Sally Sue had. They both solved it in different ways, and they both got different answers. And they came to figure out, we need to establish an order of operations so that every single person that does this problem does it correctly. And so what mathematicians a long time ago decided is, we're going to multiply and divide before we add and subtract in an expression like this. And we get a little bit more complicated when we talk about the actual order of operations, but for this particular problem here, division would come first before you do any sort of addition and subtraction. So before an order of operations was established, we didn't know who was right. Now that we have this rule that tells us what to do first, we know that Sally Sue would in fact be correct by the order of operations we have today. Okay, so again, the reason we have order of operations is that so we can all no matter who we are, get to the same answer. Okay, so now let's go ahead and review what the order of operations says. I already told you a couple of steps, but I'm going to divide it into 4 basic steps here. And the first thing I'm going to say is you do your grouping symbols first. And oftentimes your grouping symbols look like parentheses. That is the most common set of grouping symbols you'll see. But you also might see grouping symbols that look like this. Okay, so those are called brackets right there, and usually you only use those if you already have parentheses in the problem. And if you really need a third set of grouping symbols, you might see some that look like this. Those are the little squiggly marks that everyone hates to make. Those are called braces. Okay, so these would all be examples of grouping symbols. You actually might even see in some problems grouping symbols that look like this, just 2 straight up and down bars. And if you remember this at all from 5th or 6th grade, those are called absolute value bars. You probably won't see any of those here in this unit, but that's another example of grouping symbols. So anything inside grouping symbols, we always do that first before we do anything else. Then once we do what's inside the grouping symbols, we go to our exponents next. So you do any exponents you have after you've done what's inside the grouping symbols. Once exponents are done, then you go ahead and you do multiplication and division from left to right. Now this is where some people get a little bit confused. Multiplication and division, there's a reason I'm putting those in the same step. Okay, and this is, again, left to right. You don't necessarily have to do multiplication before division, okay? You just have to, based on what's written left to right, do those in order from left to right. So you might do division before multiplication, you might do multiplication before division, just depends on the problem. You just go from left to right on these 2 operations. And then the same thing is true of addition and subtraction. Some problems you'll add first, some problems you'll subtract first. You just go from left to right after you do all of your multiplication and division. So adding and subtracting should be the very last thing you do in order of operations. And we have a little saying that goes along with order of operations that you may remember. If we take the first step and we just say that's parentheses, it's really grouping symbols, but if we take the P from parentheses, P-E-M-D-A-S, parentheses, exponents, multiply, divide, add, subtract, you might hear the phrase PEMDAS, or oftentimes we'll use the saying, please excuse my dear Aunt Sally, to remember the order that we need to do our operations. Please excuse my dear Aunt Sally. Okay, so now let's just jump into number 1 and see if we can remember how this works. So number 1, we have 6 minus 10 divided by 5. So we just have 2 operations there. I see some subtraction and some division. So we don't need to worry about grouping symbols. There are no grouping symbols in this problem. No exponents either. So we go to step 3, which says multiply and divide from left to right. So what I'm going to do is I'm going to ignore this subtraction right here. So I'm just going to bring down this 6 because we're not going to subtract 6 and 10 yet. We're just going to bring this down. But we are going to divide negative 10 and 5. And you have to remember that this 10 is a negative. So you need to be really, really careful with your signs, just like we were in the last unit. Negative 10 divided by 5 is negative 2. So on my next line, I'm going to write 6 minus 2, because this is a negative 2. Make sure in your homework that you're showing your steps vertically, just like I'm doing. That's going to make it really, really nice and organized, easy for me to grade, and easy for you to see how you did. So keep everything in a nice vertical column, one step at a time. So now that we've done our division, now we can do what's left, which is just subtraction. So 6 minus 2, that's going to give us 4. And so 4 would be the answer to this expression. Okay, now let's look at number 2. We have 3 times 6 minus 4 squared divided by 2. Okay, so I don't have any grouping symbols for this one, but I do have an exponent. Okay, I have an exponent right here, 4 squared. Okay, so when you take 4 and you square it, that's like taking 4 times 4, that's going to give you 16. So that's the part I'm going to simplify first. Everything else I'm going to leave alone, but this 4 squared right here is going to become 16. And then everything else I'm going to bring down in the order it's written. 3 times 6 minus 16 divided by 2. Okay, so now my exponents are done. Now I'm going to move on to multiplication and division from left to right. Well, my first operation I see is multiplication, so now I can go ahead and do that. I've got a 3 times 6 out here first. So 3 times 6 is 18. And then I have 18 minus 16 divided by 2. Everything else just gets brought down. Okay, I'm still on step 3 now. I've done my multiplication, but I still have division in the problem. So this 18 minus 16, I'm going to ignore that subtraction for the time being, and I'm going to skip ahead to this division over here. So this is a negative 16 divided by positive 2. Negative divided by a positive, you're going to get a negative. 16 divided by 2 is 8, so this would be minus 8. And then this 18 out in front will just bring this down. So now we have 18 minus 8, and so now we can do our last step, this subtraction. 18 minus 8 gives us positive 10. So your answer to this would be positive 10. Okay, what I want you to do now is hit pause in the video and try number 3 on your own, please. Once you're ready to check, hit play to check your answer. Okay, let's check and see what you got. So the first thing you should have done was your exponents. You have a 2 squared down here at the end. 2 squared is the same thing as 2 times 2, which is 4. So you get 4 times 7 plus 4 divided by 4. Next step in order of operations is to multiply and divide left to right. So I can multiply my 4 times 7, which is 28. So now I have 28 plus 4 divided by 4. Then I did my division. Positive 4 divided by 4 is positive 1. So 28 plus 1, and that gave me 29. Okay, let's go ahead and try number 4 now. So number 4 here, we have 25 minus 8 times 2 plus 3 squared. Again, no grouping symbols in this one, so the first thing I'm going to do is my exponents. I have a 3 squared, which is the same thing as 3 times 3, so that gives me 9. So I have 25 minus 8 times 2 plus 9. Now I'm going to do multiplication and division left to right. So my first operation I see here is subtraction. I'm going to ignore that, so I'm just going to bring down my 25. But I do have multiplication next. I have a negative 8 times 2. Negative 8 times 2 is negative 16, so this becomes a minus 16. And then we bring down our plus 9. And now we have no more multiplication, no more division either. So now I have only addition and subtraction left. I can just work this left to right now. That is just addition and subtraction. So 25 minus 16 is going to give me positive 9. So I get 9, and then this plus 9 out here. 9 plus 9 gives me 18. So my answer is positive 18. Okay, 2 more that I want to try. Number 5, this one we're adding some grouping symbols now. And we actually have 2 sets of grouping symbols. My first set is pretty obvious. We have this set of parentheses right here, 5 squared minus 3. But you also have a set of grouping symbols that's really invisible up here in this numerator. If you look up here in this fraction, we have the fraction 5 plus 3 over 2. Anytime you have a quantity, a sum, or a difference all by itself in the numerator, you want to think about an invisible set of parentheses being up here as well. So what that tells me is I'm going to simplify, do what's up there in the numerator first, as well as what's here in parentheses first, before I do anything else. So if I start up here with this numerator, I'm going to simplify 5 plus 3 first, again just because it's in a numerator by itself, so it's like it's in its own set of grouping symbols. So 5 plus 3 is 8, so that gives me 8, and then I've got my fraction bar over 2, plus, and now I have this set of parentheses here, 5 squared minus 3. Okay, so now I'm going to leave my 8 over 2 alone, and I'm going to focus on what's inside this set of grouping symbols. Inside this set of grouping symbols, we have 2 things. We have an exponent and subtraction, so we need to also follow order of operations inside my grouping symbols here. So that tells me I'm going to do my exponents first. So 5 squared is 25, and then it's minus 3. I need to keep that inside parentheses because I'm still not done with it yet. So now I have 8 over 2 plus 25 minus 3 is 22. So now I can take this out of parentheses now that I've simplified everything inside, and that becomes plus 22. Okay, so now I have 8 over 2, and I have addition here. If you remember, a fraction bar means divide, so really I have division and addition here. I know division needs to come before addition, so I'm going to divide my 8 and my 2. 8 divided by 2 is positive 4, so now I have 4 plus 22. And 4 plus 22 is 26, so my answer for this one is positive 26. Okay, last example, number 6. We have 8 divided by the quantity. Remember, that's how we say it, that parentheses there, 9 minus 7 to the third power, plus the quantity, 13 divided by 2. So order of operation says I do what's inside grouping symbols first, so I'm going to simplify what's inside this set of grouping symbols right here, 9 minus 7. So I get 8 divided by 9 minus 7 is 2, so this becomes 2, and it's still got the third power attached to it, this exponent of 3, so I'll write that, plus the quantity 13 divided by 2. Okay, so now I still have some grouping symbols. I have grouping symbols right here, 13 divided by 2, so I need to simplify that. So this gives me 8 divided by 2 cubed plus 13 divided by 2 is going to give me a decimal that's going to be 6.5. So plus 6.5. Okay, the next step in order of operations is to do my exponents now that my grouping symbols are done. So right here I have 2 to the third power, or we sometimes say 2 cubed. This is 2 times 2 times 2, and 2 times 2 times 2 is in fact 8. So this gives me a positive 8. So now I've got 8 divided by positive 8 plus 6.5. Okay, now we have division and addition. So division comes before addition. We're going to do 8 divided by 8, which is positive 1. So we get 1 plus 6.5. And then my last step finally is to add 1 plus 6.5, 1 plus 6.5. If you need to line up your decimal points, that's the same thing as 6.5 plus 1.0, and so that gives you 7.5. Okay, any questions you have over this video, feel free to jot them down, go back and rewatch anything you need to. Until I see you next time, have a nice day, you're all wonderful people. Take care.